Good evening. It's Sunday, August 30th, and we're here at SpaceX headquarters in Hawthorne, California. You're looking at a live view of the Falcon 9 rocket as it awaits its 7:18 p.m. Eastern Time launch from Cape Canaveral Air Force Station in Florida. My name is Michael Andrews, and I'm a supply chain supervisor here at SpaceX. For tonight's mission, we'll be placing the Saocom 1B Earth observation satellite into a low Earth sun-synchronous orbit for the National Commission of Space Activities of Argentina, known as CONAI. Now, it's the second and final satellite of our Saocom constellation. If you recall, SpaceX launched the first satellite, Saocom 1A, back in October 2018 from Vandenberg Air Force Base in Florida. The satellite's main goal is to gather soil moisture information. The data provided by Saocom helps increase productivity and competitiveness of sectors like agriculture by generating, for example, risk maps that can help control crop diseases, by implementing efficient fertilizer systems, and for early flood warnings. The two Saocom satellites will work in partnership with Italy's Cosmo SkyMed constellation. All the satellites will work together to provide Earth imaging. Each Saocom satellite can acquire about 225 images every day. We also have two smaller Rideshare satellites on board, Tyvak-0172 and the GNOMES-1 small sat for PlanetiQ. Now, PlanetiQ designs, builds, launches, and operates one of the most advanced constellations of radio occultation weather forecasting satellites. Radio occultation is a technology that measures and analyzes the signals generated by GPS satellites to determine weather data, such as pressure, temperature, and water vapor. This data is used in weather forecast models to greatly improve the accuracy and extend the range of those weather predictions. Now, tonight's launch is an especially exciting one. It's SpaceX's first polar orbit from the East Coast. A polar orbit is one in which satellites pass above the North and South poles as opposed to the equator. This is the first polar trajectory since the late 1960s flown out of Cape Canaveral. SpaceX worked closely with the Air Force and the FAA to create a trajectory that meets the necessary safety requirements for flight. Falcon 9's autonomous flight termination system, its exceptional reliability, and its improved performance over heritage launch vehicles is a key factor in why SpaceX is able to meet the unique performance and safety challenges of launching this polar mission safely from the Cape while still delivering the payload to its desired orbit. Due to the flight path tonight, people along the eastern coast of Florida, including Miami, may be able to see Falcon 9 as it launches to space, as well as our second stage burn following stage separation, and maybe even the first stage boost back burn as it makes its way back to Earth for landing. And because of the time of the day of launch, about 30 minutes before sunset, we might get nice illuminations of the contrails if clouds aren't in the way. Now let's take a look at Falcon 9 out on the pad at the Cape.
Good evening. My name is Andy Tran, and I'm a production supervisor here at SpaceX. We're looking at a live view of Falcon 9, our 70-meter, two-stage liquid-fueled launch vehicle as it sits at Cape Canaveral. The bottom two-thirds of the vehicle is the first stage. Its objective is to accelerate the vehicle through the Earth's atmosphere and then separate from the rest of the rocket. For today's mission, it's going to be the fourth flight for this particular first stage booster. It previously supported two cargo resupply missions, CRS 19 and 20, as well as our 9th Starlink launch in June of this year. Like its previous missions, we are going to be attempting to recover this booster, but this time back at land on Landing Zone 1. Now, after the first stage separates, the second stage will then carry the Saocom 1B and our two Rideshare satellites to a sun-synchronous orbit. Sun-synchronous orbits travel over the Earth's poles as the planet rotates underneath, with the satellite passing over a particular section of the Earth at the same time each day. This type of orbit also provides a constant amount of sunlight, making them especially good for imaging satellites like the ones we have on board tonight. At the top of the rocket, you'll notice a large nose cone. This is called the satellite fairing. It's a composite structure and protects the rocket from the forces of ascent and also houses our payloads. Once the vehicle is outside of the Earth's atmosphere, the fairing will separate to expose the satellites into space. For tonight's mission, both fairing halves are brand new. We only have one recovery ship supporting today's mission, Miss Chief, you can see on screen right now. So we won't be able to attempt to catch these fairing halves, but rather try to scoop them out of the water once they land. The other recovery vessel, Miss Tree, was positioned to support today's Starlink mission, which has now been rescheduled for later on this week. And finally, the large truss structure next to Falcon 9 is called the Transporter Erector, or TE. The TE's job is to roll Falcon 9 out to the launch pad, raise it to a vertical launch position, and also route power, fluids, and communication to the rocket and satellite.
Falcon 9 rolled out to the pad with the payload on Friday evening and went vertical yesterday at 2 p.m. Eastern Local Time. The SpaceX chief engineer held a technical poll at T-minus 1 hour, and our launch director held a propellant load and launch go, no-go poll at T-minus 38 minutes. If we do have to call a hold on today's launch for any reason, we do have a backup opportunity tomorrow, same time, pending range acceptance. In terms of fuel, Falcon 9 began loading propellants at T-minus 35 minutes, and that process is still currently underway. Falcon 9 uses a refined form of kerosene called RP1, Rocket Propellant 1, for its fuel, and super chilled liquid oxygen, known as LOX, for the oxidizer. Currently, RP1 is nearly fully loaded on the first stage, about 36,000 gallons, and the second stage is fully fueled at about 9,600 gallons. Liquid oxygen, though, it's still loading on both stages. In terms of helium, we've also begun to load helium into Falcon 9. The vehicle uses helium gas as a pressurant and helps push the RP1 and LOX through the Merlin engines. Think of like your car, gravity keeps all the fuel at the bottom. We don't have that luxury in zero gravity, so the helium pushes that fuel to our engine's turbopumps. And then at T-minus 7 minutes, our engine chill process will begin. This is where we allow a small amount of the super chilled LOX to flow into the Merlin engine's turbopumps prior to the full flow of LOX into the vehicle. This helps us avoid any kind of thermal shocks to the system. That LOX is negative 338 degrees Fahrenheit after all. Finally, the transporter erector will retract away from the rocket slightly at around T-minus 4.5 minutes, and this provides enough clearance for Falcon 9 to lift off. The vehicle is healthy, and we, the folks in Mission Control, are currently working no issues on the rocket. In terms of the payload, at T-minus 15 minutes, the Saocom 1B satellite finished transitioning from external to internal power. Our two Rideshare small sats were already on internal power before the countdown began. It's been a busy weekend at the Cape with a lot of launch opportunities, but the range is approving us and accepting this launch attempt. But weather, let's talk about weather. We know that it did postpone our Starlink launch earlier today, and it does have a real chance of doing that again for this mission. There are a lot of storm cells being generated in Central Florida, and they're heading east towards the Cape. We're still monitoring that situation, and we probably will down to the last minute. But barring weather, all systems continue to be go for a liftoff at 7:18 p.m. Eastern Time.
Tonight's launch is of the Saocom 1B satellite for our customer CONAI, the government of Argentina's National Civilian Space Agency. Saocom 1B is part of a two-satellite system that will use a radar technology known as synthetic aperture radar, or SAR, to monitor the Earth. As we mentioned earlier in the webcast, SpaceX launched the first of these satellites, Saocom 1A, in the fall of 2018. With the launch coming up in just about T-minus 6 minutes and 30 seconds, let's take a closer look at the capabilities of the Saocom 1B satellite.
All right, we're currently less than 4 minutes from liftoff. Falcon 9 is now moving into the final stages of the countdown. The vehicle remains in good health, but the weather is actually now go. The status has changed last minute. In terms of fuel, the first and second stages are now fully fueled with RP1. LOX loading will continue for the next few minutes. And also one thing you'll hear 1 minute before liftoff, you'll hear the announcement that Falcon 9 is in startup mode. This means that the rocket's own internal computers are now autonomously controlling the launch countdown. The Saocom 1B payload continues to be healthy. The Falcon 9 team is tracking no issues on the rocket. Weather has just recently opened up and is looking good, and the range is green for launch. As a reminder, if we don't launch today, we do have that backup opportunity tomorrow, pending range acceptance at 7:19 p.m. Eastern local time. And with just under 3 minutes to go before launch, let's listen in to the final countdown prior to liftoff. All right, our 9 Merlin engines on the first stage are chilled. They're ready for flight. The LOX loading will complete on that second stage in just a few seconds. Once that occurs, you'll start seeing more of this white clouds venting.
Stage 2 LOX closed out.
And as our LOX is fully loaded and it's topped off, you'll start seeing this condensation, these clouds form more and more right up until liftoff.
Falcon 9's in startup.
All right, we have entered startup mode. Falcon 9 has taken over the remainder of the countdown. We're just waiting for the go for launch callouts.
Stage 2 present for flight.
LD, go for launch.
T-minus 30 seconds. T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. And liftoff of Falcon's first East Coast polar launch, Ola, Argentina.
Stage 1 course nominal.
We're now 40 seconds in the flight. Falcon 9 has taken off. It's cleared the tower, and we're currently throttling down to prepare for maximum Q. That's the point of maximum aerodynamic pressure. It's at 1 minute, 12 seconds.
Vehicle is supersonic. Vehicle has reached maximum aerodynamic pressure.
you've heard it. We've reached max Q. At this point, the loads in the vehicle become less and less as the atmosphere gets thinner. We're now able to throttle those
Vehicle
Merlin
clear,
engines
okay.
back up. And at its maximum power, like right now,
And the
the vehicle
engine chill
consumes
started.
more than 700 gallons of fuel per second. All is looking good with our first stage's trajectory. The next couple events, there are 5 events, one after another. First, our main engine cuts off on our first stage. The stages will separate. Our first stage will then flip around to begin its landing attempt. The second stage's Merlin vacuum engine will ignite for second engine start 1. The first stage's boost back burn will start. It's one of 3 burns to help us land. They occur one after another in about 15 seconds. And this is that first polar orbit. If the clouds, you can see through the clouds here, you'll see some unique views that you haven't seen from Falcon 9 over Florida.
And we have Miko.
Stage separation confirmed.
And ignition.
All right, all of those events happen successfully one after another. This boost back burn, it'll last about 40 seconds. And so you see it on the left-hand side of the screen. On the right-hand side, you will see our second stage carrying those 3 satellites to orbit. And coming up next in about 20 seconds, that boost back burn will end, and then we'll have our fairing deployment.
Stage 1 boost back shutdown.
All right, one of those first landing burn, the boost back burns has successfully ended. Our 2 fairing halves will now jettison to expose the satellites to space. And you see the first stage has already been a turnaround, and you can see the nitrogen from our attitude control system helping guide it back.
Fairing separation confirmed.
There you see our 2 fairing
Acquisition
halves
signal, Bermuda.
have jettisoned. You can even see them in the background there on our MVAC engine, and you can see them from land too. It'll take us some time to get those to come back down. We'll keep you posted on the update.
We are T plus 4 minutes and 13 seconds into flight. Everything is looking great for tonight's mission. On the right-hand side of your screen is a view of our second stage, specifically its Merlin vacuum engine. We also call it MVAC engine for short. It's currently in the first of its 2 first and only planned MVAC burn. The first burn should last for about another 4 minutes. On the left-hand side of your screen is a view of our first stage looking downward. It's continuing to fall back towards Earth. The next milestone for the first stage is its first stage entry burn. Falcon 9 needs to execute an entry burn to slow itself down before hitting the dense parts of the atmosphere. Without this second burn, relying on the atmosphere alone to slow Falcon 9 down would put unnecessary strain on the rocket. That entry burn is coming up at T plus 6 minutes and 10
Second stage
seconds.
is following nominal trajectory. Acquisition of signal, South Texas.
You may have also noticed that we've deployed our 4 hypersonic grid fins. Those are the honeycomb-like structures that you see on the left-hand side of your screen. They help to guide the first stage back during descent by moving the center of pressure on the vehicle. Again, those bursts of gas are nitrogen. It's absolutely normal, and those help to orient the rocket during its descent back towards Earth. And we're about 20 seconds away from our second burn, the entry burn.
Stage 2 FTS has safed.
Stage 1 entry burn startup.
And 3 Merlin engines have relit and are currently slowing the first stage down before it hits those dense parts of the atmosphere. Second stage on the right-hand side of your screen is continuing to perform as expected.
Stage 1 entry burn shutdown.
And that is our second burn completed. And as we mentioned earlier, we are going to be attempting to recover this booster back at land on landing zone 1. The first stage has one more burn left.
Is saved.
That is the landing burn. It begins just before we touch down and provides the booster with a soft descent before we land. During this period, the landing legs will also be deploying. You might be able to catch it right before we touch down. They're stowed at the base of the vehicle and made up of state-of-the-art carbon fiber and aluminum honeycomb.
Stage 1 transonic.
You can see the Cape getting closer and closer. What a cool view. The first stage is passing through the cloud layers right now.
Stage 1 landing burn startup.
And here comes Falcon 9 attempting its 4th landing.
Stage 1 landing leg deploy.
And you could not ask
Stage
for
1
a
landing
better
burn.
landing than that. Falcon 9 has landed once again. That is number 4 for this first stage booster and the 58th overall of an Orbital class rocket. What a way to start off tonight's mission. The second stage and our primary mission are still continuing and remain healthy. The next milestone for the second stage is second engine cutoff 1, also known as SECO-1, and that is coming up at T plus 10 minutes and 5 seconds. During second engine cutoff 1, we'll be shutting down the second stage's MVAC engine. And as we approach this period, we'll be listening very closely for 2 callouts: verification of SECO-1 and then confirmation of a good orbital insertion. Both are going to be critical to ensuring that we deliver all 3 payloads to their intended orbits tonight. And while we're waiting for that period, some fun facts. The engine you see on screen can produce over 200,000 pounds of thrust. The second stage is currently traveling at over 20,000 kilometers an hour. At those speeds, you could travel from Los Angeles to New York in just 12 minutes. Very, very fast. We're about 20 seconds away from second engine cutoff 1.
And we have SECO.
And the second stage Merlin vacuum engine has successfully had SECO-1.
Nominal orbit insertion.
And that is the other call out we were waiting to hear on, a good orbital insertion. In just about 3 minutes, we will have the first of our 3 deployments. Until then, we are going to take a short break and be back around the T plus 13 minute mark for the deployment of the Saocom 1B satellite.
Also signal Bermuda as expected. Acquisition of signal, Peru.
Well, welcome back from our mini coast phase. For those of you just joining us, we successfully launched our Falcon 9 rocket from Cape Canaveral on a polar orbit trajectory. We had a successful stage separation, a successful land landing, the fourth landing for this booster, and we're waiting the deployment of the Saocom 1B satellite. It's just about 10 seconds, 15 seconds away. It's the second and final satellite in this constellation. We first launched its sister satellite, Saocom 1A, in the fall of 2018.
Saocom separation confirmed.
All right, you've seen it, we heard it. Successful deployment of that Saocom 1B satellite. And as a reminder, this satellite and Saocom 1A's satellite's goal is to gather soil moisture. It helps increase the productivity and competitiveness of the agriculture sector. It helps us generate risk maps that can help control crop disease. It helps implement better fertilizer systems and provide early flood warnings. These two Saocom satellites work together with Italy's Cosmos SkyMed constellation, and they work together by providing up to 225 Earth images per day. But we still do have two satellites left to deploy. We're going to go into another coast phase. This one will last about 45 minutes. We're going to take a break, but we're leaving you with an animation that shows where we are in that coast phase. We'll be back at about T+1 hour for the deployment of the Tyvak-0172 and GNOMES-1 Rideshare satellites. We'll see you then.
Welcome back to the webcast of the Saocom 1B mission. If you're just joining us, we're wrapping up our coast phase and close to the end of today's mission, which launched this evening at 7:18 p.m. Eastern. We then had successful lighting and shutdown of our second stage Merlin vacuum engine, then a successful deployment of the Saocom 1B satellite for Argentina's national space program. Coming up, we have the deployment of our two Rideshare satellites. First up is the GNOMES-1 satellite for PlanetiQ that occurs at T+1 hour, 1 minute and 37 seconds, followed shortly after by the Tyvak. It's about the size of a carry-on bag, weighing about 39 kilograms or 86 pounds. We're a few seconds out from the GNOMES-1 payload deploy.
PlanetiQ separation confirmed.
And we did get confirmation that the GNOMES-1 satellite did successfully separate. We're now waiting on our final deployment today, and that is of the Tyvak-0172 satellite. And for this one, we should be able to see the deployment. We're just about 15 to 20 seconds out.
Tyvak separation confirmed.
And we did get confirmation of the Tyvak-0172 satellite separation. That is our last payload for tonight. It's been an exciting evening. We saw a successful liftoff from our Cape Canaveral Air Force Station launch pad. at 7:18 p.m. Eastern, the first polar orbit launch for SpaceX at the Cape, and the first originating from Florida in decades. From there, a successful stage separation, a land landing of our first stage back at Landing Zone 1, which marks, and this is a small correction, the 59th landing of an orbital class rocket, not the 58th. And finally, the deployment of the Saocom 1B satellite for the Argentinian Space Agency, along with our 2 rideshare customers. With that said, we will be bringing our webcast to an end.
But before we go, we'd like to thank our customer Konai for tonight's mission and their great support, as well as rideshare customer PlanetiQ. We'd also like to thank the United States Air Force for range support, as well as the Federal Aviation Administration for the licensing of today's mission. Please continue to follow us on SpaceX.com for future missions and milestones, as well as our Twitter and Instagram profiles. And if you're as excited by what you've seen tonight as we are, and you want to join our team, please visit SpaceX.com/careers to learn more about working with us at SpaceX. And finally, thank you to you, all of our viewers, for your support and for tuning in. We hope you have a great night.